With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
The given question is, the figure represents two snaps of a traveling wave on a string of mass per unit length mu equals to 0.25 kg per meter. The first snap is taken at t equals to 0 and the second is taken at t equals to 0.05 seconds. So we have to determine the speed of the wave and the frequency of the wave, and these are the options, and in the option these are for the speed of the wave. So now coming to the figure, this is the two snaps shown for the traveling wave, one at t equals to 0 with the solid line and one at t equals to 0.05 second with the dotted lines. So here we can first of all assume the general equation of this traveling wave as a sine. See one thing, at t equals to 0, this is the this is the solid line. At t equals to 0.05, this is the dotted line, the traveling wave. Okay, so we can see from here that as the time is passing, the wave is traveling in the positive x direction. So we can write here a sine kx minus omega t plus phi. Okay, so this is representing the general equation of this given traveling wave. So now first of all we have, see, at x equals to 0, at x equals to 0 and t equals to 0. Okay, means at this position we have the displacement of the particle as 5. Okay, see, 10 is the maximum amplitude. The amplitude of the given wave is 10 and we have the particle at 5. So y is equals to a by 2 at this position, x equal to 0 and t equals to 0. So this is a sine. So putting x and t equal to 0, these two terms will become 0 and we will be left with phi only. And from here, this a and a will cancel out and we will get phi will be equals to pi by 6 radians, right? Further, at the instant of x equal to 0 and t equals to 0.05, our particle is at this position, right? At y equals to 0, we can write here at x equals to 0 and t equals to 0.05 seconds, we have our particle at y equals to 0. This is the displacement. So we can write 0 equals to a sine. Now as x is 0, so we will be left with minus omega into t is 0.05 plus phi. Okay, plus phi. So now for this term to be 0, this phase term must be 0. So we will have from here phi equals to 0.05 times of omega, and we can write omega will be equals to phi divided by 0.05, which we can write as 20 into phi, and the phi value is pi by 6. So we can write omega will come out to be, this we will cancel out by 2, so this is 10 and this cut by 3, so this is 10 pi by 3 radians per second. So from the angular frequency we can find the frequency, which is given as omega over 2 pi. So we can write this as 10 pi by 3 into 2 pi. So from here pi and pi will cancel out and this will cancel out by 5. So the frequency of the traveling wave will be found out to be 5 by 3 hertz. Okay, so this is one of the answer. And further we have to find the velocity of the wave. Now to find the speed of the wave, we have, it is given as frequency into lambda. Okay, where lambda is the wavelength. So if we talk about the wavelength, and for the snap at t equals to 0.05 second, this is the position here, and we can see that the wave is having one complete cycle is having the length of 2 meters, right? This is given in meter. So the wavelength of the wave for one complete cycle is 2 meters. So we have here lambda is equals to 2 meters. So we can simply write the velocity or the speed of the wave as given as lambda into frequency. So this will be nothing but 2 into 5 by 3. So this will give us velocity as 10 by 3 meter per second. So this is the required value of the velocity. And from the given options we have A, B, C and D. Option B is the correct answer. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.